Okay guys, after knowing that about the rotation about the current axis and the rotation about the fixed axis, if you remember, I want to summarize that if you have rotations about current axes, so you're gonna go like this. You're gonna go forward rotations, right? So, but if you want to have rotations about fixed frames or axes, so you're gonna go backward. And the example of this is what is for the forward was tell me. Let me go on. So the Euler angles. Remember Euler angles that we derived together in the last class, and this is roll, pitch, yaw. Remember, roll and pitch and yaw. That's right. So this is very important that you know that you are doing the rotations forward, you are multiplying in the forward and the backward. So I have taught you this in part 5. Now the most important things that you have to know in robotics is, as I promised you, is homogeneous transform. Homogeneous transform. So this is super important, guys, that I'm putting several stars here. Because when you're deriving the equation of the motion of the robot, that you have to know this, okay? So it means combining both orientation means rotation, orientation, and displacement or position gives you what? Gives you homogeneous transformation. Homogeneous transformation. So let me start with a very simple example. Suppose that you have a planar, this fixed frame, O0, X0, and the Y0, right? So for the first rotation, we are rotating this for the angle of theta, and so what you get is, here we go, X1 and the Y1, and this is obviously O1, and this angle of theta, understand? So if you assume that originally we had a point P on the fixed frame, this P1, right? After rotation, it's gonna come here, that's right, say, gonna be P2, that's right. Now we are making another motion. So another motion is, we are transferring this O1, X1, Y1, this coordinate frame, to here, to this point. I'm changing color. So I'm transferring. This is translational motion, that's right. So it's gonna be, there is no rotation, only I'm transferring the origin of this here, that's right. So the point P2 gonna be transferred here. So I'm gonna name it 3. So only I transferred to this. See? This. Right? I only transfer the origin, so O2 x2 y2. There's no rotation, only translation. So now if you connect the final point that is transmitted, let me choose this color, green, to the fixed origin, this, and name it V3. That's right. Clear? So you can simply say, so first of all, let us say, so O0 x0 y0 for the rotation of theta transmitted to 1 O1 x1 y1. Yes or no? Then O1 x1 y1 for displacement of, I don't know, D went to O2 x2 and y2. So sorry, yes, I have no corona. So this is rotation plus position, that's right, or displacement plus position. Understand? Hold on, I have to fix this. So now, based on the algebra, you know that this vector v3, this vector green, is the sum of this purple, this I'm saying v2, and this, that's right, I'm saying v1. Do you care? This is vector summation, that's right. So we know that simply vector v3 from high school is v2, this, let me change the color, v2 this plus vector v1. That's right. So v1 is du to a rotation matrix. Right? On the other hand, you can say v1 respect to 0, this what? R1 respect to 0, that's right, in P2 respect to 1. That's right. Clear? Hold on. I don't know why it's ripping. Okay. Or R2 respect to 0, P3 respect to 2. That's right. Because we only translated P3 by P2. That's right. But P2 is a result of rotation. So gonna be P2 respect to coordinate system 1, this. That's right, orange one. And R1 respect to 0. Or P3 respect to 2, because there is no only translation, but again R2 respect to 0. Understand? This is very clear. Because again, O2, X2, Y2 happened because of a translation of O1, X1, Y1. There is no rotation, only translational motion. But O1, X1, Y1 is the result of a rotation theta. So P3 or P2, they are result of a rotation or rotation matrices. That's right, you see here. So V1 respect to 0 is P2 in P2 respect to coordinate system 1 and rotation matrix, or this. Understand? So, but we know that V2 is only due to a translational motion. Translational motion. How much? This I'm naming this displacement of origin of 2 with respect to 0. I'm saying like this. That's right. That's right. Origin of this O2, X2, Y2 with respect to the fixed coordinate system. So this is D2 with respect to 0. So on the other hand, P3, the result, this point after the rotation and then translation, so respect to 0 is gonna be R1 with respect to 0 rotation matrix that I taught you, P1 plus D2 with respect to 0. Here we go. Now we have both translational motion and rotational motion. And this is very clear, guys. So on the other hand, guys, if you, so see, so P3 is this translational, but also rotation of point 2 or point 3 with respect to what? With respect to coordinate system 0. Understand? It is very clear. That's right. So this says, I'm just explaining more for those of you. This says we are rotating point 1. Let me show you this. We are rotating point 1 for the angle of theta. For the angle of theta means rotation matrix. That's right. Now you know how to calculate that. Then we are transferring everything for this distance. Then we are transferring this to this distance. Here we go. That's right. Simply means like that. And this is completely right. Understand? So this part is orientation. And this part is what? Displacement or translational motion. Displacement. Again, I'm explaining. It says point 3 respect to the fixed coordinate system O0, X0, Y0 is P1. This point at the ordinate at the fixed frame. When you're rotating that, gonna get the P2. So this is orientation or rotation. That's right. Then we are transferring everything P2, O1, X1, Y1 to displacement. This displacement D2 with respect to the 0, and we get the result. Understand? Now let me make it more general. Okay. Recording, yes. How? Look at this. You have this fixed coordinate, and you have point P on that, say P0. Then what I'm doing, I am transferring the origin of this to O1, and then I'm rotating at the same time. What the hell is this? So also I'm rotating this fixed frame to the angle of theta 1. Angle of theta 1. So it's going to be O1, X1, and the Y1. Right? So what we are doing, it's going to be, say, P1, the new transferred. That's right. Then what I'm doing, I'm transferring everything from this origin to new one. Okay, to say this color, to O2, X2, and the Y2. That's right. Y2. For which angle? I'm translating rotation for theta 2. That's right. So this is gonna be, let me put this here because Y2, this is gonna be your final point, P2. Now if I ask you find the position of P to respect to the origin, fixed origin, so what you're gonna do? You're gonna say this p respect to the zero gonna be what? Gonna be r1 respect to 0, p respect to the 1. Oh, here is 1. I'm getting older, guys. P respect to the 1. That's right. Huh? Plus this translation d1 0, displacement of frame 1 respect to 0, as we did above. Here we go. Now p1, this p now respect to the 1, that's right, is equal to r, because you have a rotation, r2 respect to 1, and p2, that's right, plus now d2 respect to 1, understand? Yes. So what I'm gonna do now, I'm gonna replace this inside here. So the final position of p respect to 0 gonna be r1 respect to 0, r2 respect to 1, p2, plus d2 respect to 1, plus d1 respect to 0, right? So if you expand that, you're gonna have r1 respect to 0, r2 respect to 1, and p2. And we know this, I taught you exactly, that's right, because you have two rotations. So p2 has a rotation component. This is, remember, p2 means p2 respect to 0, and p respect to this, p2 respect to the coordinate system, that's right. So p respect to this coordinate system is rotation of 2 respect to 1, rotation of 1 respect to 0. Remember, I taught you in part 4 probably, that's right. Plus r1 respect to 0, d2 respect to 1. See, this d2 you have to multiply by this rotation matrix to give you in this coordinate system. That's right, understand? Because x1 is rotated by theta 1. That's right. Plus d1 respect to 0. Because d1 is already expressed in x0, y0. So you have to rotate this by the rotation of theta 1. And this is translational part. So this is translational part. This is rotational part. Right? So you can, let me change the color. You can show it in the matrix form. You can show it in this form. See, r1 respect to 0, r2 respect to 1, and now this d1 respect to 0 plus r1 0, d2 respect to 1, 0 and 1. Here we go. Understand? So this is that you can show in the matrix form, and this is respect to, this is respect to with respect to O0, x0, y0, because we are measuring everything in robotics based on the fixed frame or coordinate system. Understand? So making the today lesson, we're gonna call the homogeneous transformation, or H, homogeneous transformation, as this, generally speaking: rotation matrices, translational motions, zeros and 1. And this is super important, guys. This is that you have to know. This is you have to know in the robotics. This is homogeneous transformation. Okay? So let us do some examples. Example. If I say find homogeneous transformation of x and a, means you only have translational motion, there's no rotational motion. Means this, look at here guys, I want to find the homogeneous transformation of this translational x and s. So here is x, y, and the z. That's right. This is x naught, y naught, z naught. I'm saying move everything for the distance a along with x-axis. So you're gonna have this, say for example, here we go. This is gonna be x1, y1, and the z1, and this is o1, this is o0. So the homogeneous transformation, so do we have any rotations? No. So your rotational part, guys, you have to do always like this, because on the other hand, having the directional cosines, angle of x1 with respect to x naught is 0. That's right. So because they are parallel. That's right. So it's going to be 1. Angle with respect to this 0, 0, 0, 1, 0, 0, 0, 1, because we don't have any rotation. We are only translating everything. And now d part, the only displacement or translation that happens is along with x for a. That's right, for a. That's right. I mean, don't understand this. This is a. That's right. So only you have displacement in x. So you're gonna be a 0, 0. Understand what I'm talking about? It is a 0 and 0. Of the origin O1 with respect to O0. So O1 only change in this direction, A. O1 in y direction doesn't change, 0 in the z direction doesn't change. So now you have to put 0, 0, 0, I mean this, and 1. So this is homogeneous transformation for this translational motion. So if I say another example, translational motion of yn minus b, so you can simply write h is, again, h is 0, 0, 0, 1. So there is no rotation. So again, 1, 0, 0, 0, 1, 0, 0, 0, 1, because there is no rotation. Only you have the origin of y1, means this. Let me change the color. So we came here. See? It's gonna be, say, x2, y2, z2, and this is O2. Here is minus b, origin of this with respect to this, but in which direction? Y, minus b and 0. Understand? Huh? So if I say, so you do please this as practicing translational z and a. Please find this, because this is very trivial and simple. Okay, it's homogeneous transformation. Okay. Now, if I say another example, if I say find the homogeneous transformation of rotation x for the angle of alpha, so this is very easy. Only we have rotation. That's right. Look at here. So O0, x0, y0, and the z0. I'm saying we have rotation of around axis x for the angle of alpha. So what we're gonna have this, right? Here we go. So it's y1 and the z1, and here is how much? Alpha. So homogeneous transformation of this again gonna be 4 by 4 matrix, 0 0 0 1. So do we have any translation? No, because only we have rotation 0 0 0. Now, so this is gonna be x1. So x1 with respect to y0 gonna be how much? 1. That's right. x1 with respect to y0 with respect to x1, because it's normal, gonna be 0 and gonna be 0. y1 sorry, x1 with respect to y0, x1 with respect. So y1 with respect to x0 gonna be 0. So y1 with respect to y0 gonna be cosine alpha. y0 with respect to z0 gonna be sine alpha. So z1 with respect to x0, because they are perpendicular, it's gonna be 0 again. z1 with respect to y0 gonna be in the negative side that. So here is also alpha. Here is also alpha, so gonna be minus sine alpha. z1 with respect to z0 gonna be cosine alpha. So you find the homogeneous transformation for rotation around axis x for the angle of alpha. So you see that we only extended the rotation matrix to this form because there is no translation. Understand? So generally we are showing the homogeneous transformation as this nx directional cosines, that's right, nz sx sy sz, say ax ay az, 4 by 4 matrix, 0 0 0. Here is 1. Now dx translational in the x direction of the origins of the frames, of the origin of the frames, dy and dz. That's right. So again, here is translational motions of the origin with respect to each other, and this is the rotation of the axes. This is R rotations of axes, and this is displacement between origins of frames. Or you can show this as a lumped case as n, capital N, capital S, see boldface, not capital, A, D, 0 0 0 and 1. Okay. Okay, let me do a general example. Okay. Example. Based on a transformation, we rotate around, I'm changing the color because I taught you this, around current Z, let's see, no, current X to angle alpha, then we move the frame, means translational motion, frame to distance b B along D, again, current Z axis X, okay, okay, then we move the frame that we got to distance A, along the, again changing the color, current. Why I'm changing the color? Because we know the sequence of the rotation matrix, how we multiply if you are doing around the current axis or around the fixed axis. On the current axis Z, and finally we rotate the frame around the, again I'm changing the color, the current Z for angle theta. Find homogeneous transformation, guys. So because everything is being done around the current axis, I mean both rotation and translational motion, so the sequence of the multiplication of the homogeneous matrices must be in the forward direction. Remember, in the forward direction, not in the reverse direction. Okay, because we are doing around the current axes. Understand? Where is that? Okay. So now let us visualize what we got. This is X, Y, Z. That's right. X naught, Y naught, and the Z naught. We rotate around current X to angle alpha. So we are doing this. So your X1 gonna be this, guys. So here we go. For the angle of alpha, you have the first rotation. So it's gonna be Y1, Z1, and here is the alpha. Right. Then we move the frame, new frame, to distance B along the current, along the current axis X. So we are moving, get here guys, we are moving along this. That's right. So it's gonna be new, this is X1, and say Y2, Z2, and also X2. That's right. So this is what we have, Y2, Z2, X2. That's right. And this distance is B that we did. Right. Then we move the frame to distance A along the current Z axis. This is Z, that's right. So we are moving to distance A. Suppose we are moving to this, the origin of that. That's right. So this is gonna be 3. O3, that's right. x2, y2, and z2. That's right. y2 and z2. We are moving. So this distance is a origin, between their origins. This distance is a. That's right. And finally we rotate the frame around the current z for the angle of theta around this. So we have a rotation here, guys. Look at here, I'm changing the color. We have a rotation for the angle of theta. So I'm plotting the final frame that we get with green. So we're gonna have, say this. Oh, what happened? Does it scrolling? Yeah. See? So this is gonna be x3 and the y3. We are rotating around this. Understand? So we want to know the both rotational and displacement of these x3, y3 and z3. We're gonna be on this respect to our x0, y0, z0. But because I told you that we are doing all of them around the current axis, current, both the rotation and displacement, so we are going in the forward, means that we have a rotation of first current x and alpha multiplied by translational trans around x and b multiplied by another translation trans z and a, that's right, z and a multiply Yes, recording is good. So finally you have another rotation. Oh my god. Sorry guys. So finally you have, okay, finally you have another rotation. See, rotate current z, angle of theta. So you have rotation of z for the angle of theta. So we are going forward, current x, current z. We are multiplying by forward, not backward, because we are doing around the current axes. Okay, so this is how we calculate the homogeneous, where is that? The homogeneous transformation. Understand? So I'm gonna give you 2 or 3 minutes, and you extend this, and then I will do this for the next class, the result, because I want to explain too many things on this. Okay. So anyone could expand this? Please don't go. Actually, I don't do this in this class because I don't want that you cheat. I want that you expand this and do the multiplication. That's why I pause it here. So try to do this, okay, until the next class, and then I'm going to give you these matrices, and I'm going to give you the final answer. Okay, guys? So have a great weekend.